Good morning, Rob. Here we have the multiplication and squaring of binomial and trinomial task cards. Can you tell us a little bit about them?
Yeah, absolutely. One of my favorite works, Michelle, and this is one, I think we were talking earlier about some of those 3 to 6 materials that come back in 9 to 12, and I think as we were talking about earlier, there are upper elementary teachers that don't realize the roots of some of these materials, and then there are 3 to 6 teachers that don't understand the branches that this is going into. So a lot of these works are going to be familiar to primary teachers, and hopefully they're also going to be familiar to upper elementary students because they're familiar materials that they've used. We're working with the chains, and we know that we have a color mnemonic device for those chains, like the squaring and the cubing chains that are hanging in every 3 to 6 year old classroom. This is one of those uncommon materials that we're going to use like a child is going to use this when they're 3, when they're 4, when they're 7, when they're 9, when they're 12 years old. And I think some of the genius of Dr. Montessori sort of having this plan ahead that the child can use the same materials but just in a different level of complexity. So this is binomial and trinomial. It's a task card, and like any task card, we're of course looking for this to be like independent work. And so in a way, this is, if we consider like the presentation as being the first period, and then all the independent work that the child does is the second period, and then the third period is maybe when they reflect that back to us. I think task cards really fill that niche. They're that really second period. You would never show the child, here's the task cards, do them first, because the child has no basis. They're not rooted in it. And so I think that would be true in 3 to 6 as well as in elementary.
Yes.
So for this, in a primary classroom, we call them squaring and cubing chains. I know kids usually call them like the short chain and the long chain. The short chain and long chains. The actual like technical name, if you will, is the squaring and the cubing chains. Because the squaring chains, the shorter one makes a square, and the longer one makes the cube. And so we actually revisit that back when we are looking at it as a 9 to 12-year-old, because now we are looking specifically at squaring and cubing. We're looking specifically at exponents and how we write that and how we say it. And so these task cards are available for the child to work, again, after the teacher has given specific lessons in them. And this is going to take you through probably a series of 4, 5, 6 different lessons before the child's going. But of course, because they're nicely divided here, you could give the lesson for the first one. Like for instance, this first one is, write the equation for the square of this number. How you read it? Well, that's a very introductory one for an upper elementary child. And we're saying, what is this? It's, we're taking 2 beads 2 times. How do we say that? We say 2 times 2, we call it 2 squared. So you could say after this presentation, and now here are those cards that you can work on. You can work on the first section of there. And then you do the next one, which is the writing them down. How do we write 2 squared? How do we write this? And so you have another series that takes you all through those. This is how the written work. So how do we represent this? Well, this is 2 times 2. This is what it's represented, physically. Then we start moving into actual doing equations, where in your Montessori manual it might say something like a binomial times a monomial, and that's taking something like 2 plus 3 times 5. But we're still using very, very concrete materials. So again, you show the presentation, and then in my album it always says, like, child does other problems. Well, the task cards give you those other problems, and I think, especially with something like this, you can't, the child who would try to do like 34 plus 69, they're doing 2 larger numbers. That's not really what you want in the lesson. You want them to be doing smaller numbers. So rather than limiting the child, you're giving them these cards, and then certainly afterwards, once they've done them, if they come up with their own equations, they can certainly do their own. So this takes it for the binomial. Now we're taking it with a trinomial. So now we've got larger numbers taking a trinomial. So a number that's been split up into 9 plus 6 plus 4 times something. But again, it has a fully illustrated answer on the back. So the child is doing this. We still want them doing it concretely, right?
Yes.
9 to 12, we say that 3 to 6 is really, really concrete. Well, 9 to 12 is, they're still very, very concrete
Yes.
thinkers, especially when you're doing something that they haven't done before. And then, again, we move forward into, and this is a classic presentation that we do in either late upper elementary or early upper elementary, so somewhere in that 8 to 10 years old, where we're actually taking rubber bands to 100 square and we're dividing it up. And this is going to form the basis of a binomial squaring formula that we all, if we all took algebra in high school, if we all passed algebra in high school, we had to remember this, which is a squared plus 2ab plus b squared, and it's just represented very elegantly with an actual physical material. And then the task cards just give them lots and lots of experience with that. And so I can give a presentation, here are these, I can give a presentation, there are those, all the way down until the very end where we're even doing trinomial squaring. So yeah, so a great work to do independently, and most often like doing it with a friend at upper elementary. So I think you can be assured as a teacher, once you've given all the presentations and they've gone through the task cards, then you can go back and look at like, okay, what's the third period here? Have they, do they need more work? Are we ready to move on?
Okay, thank you for the presentation.
Yeah.